We now discuss the solution of a problem related to a line and a plane from the section three-dimensional geometry. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is, let the foot of the perpendicular from the point 1, 2, 4 on the line x plus 2 by 4 is equal to y minus 1 by 2 is equal to z plus 1 by 3 be P. Then the distance of P from the plane 3x plus 4y plus 12z plus 23 is equal to 0 is, we are given four options. Option A 5, option B 50 by 3, option C 4, option D 63 by 13. And we are given a line x plus 2 by 4 is equal to y minus 1 by 2 is equal to z plus 1 by 3. And the foot of the perpendicular from the point 1, 2, 4 on this line is given to be the point P. Required to find the distance of this point P from this plane 3x plus 4y plus 12z plus 23 is equal to 0. That is the given question to us. We now discuss the solution of the problem in detail. We have the given line denoted by L given as x plus 2 by 4 is equal to y minus 1 by 2 is equal to z plus 1 by 3. It is a line, straight line in 3 dimensions with the direction cosines 4, 2, 3 and passing through the point minus 2, 1, minus 1. The direction ratios of this line L are 4, 2, 3. Agreed. Given P is the foot of the perpendicular from this point 1, 2, 4 on the line L. Agreed. Now we take the line and the coordinates of any point on this line L can be obtained as follows. Take the line, equate each ratio to lambda. X plus 2 by 4 is equal to y minus 1 by 2 is equal to z plus 1 by 3 is equal to lambda. This will give rise to x is equal to 4 lambda minus 2, y is equal to 2 lambda plus 1, z is equal to 3 lambda minus 1. So any point on this line L will have these coordinates. And since P is the foot of the perpendicular from that point on L, that means P is a point on L. Therefore, the coordinates of P are also given by, 4 lambda minus 2, 2 lambda plus 1, 3 lambda minus 1 for some lambda, for some lambda, because P is any point on L. P is the foot of the perpendicular from this point 1 to 4 on this line L. And P is any point, P is a point on L. Therefore, P will have these coordinates for some lambda. Agreed. Now, we know A is 1 to 4 and P is 4 lambda minus 2, 2 lambda plus 1, 3 lambda minus 1. The direction cosines of the AP can be found out. And the direction ratios of the line joining 2 points x1, y1, z1, x2, y2, z2 are x2 minus x1, y2 minus y1, z2 minus z1. So the direction ratios of AP are given by 4 lambda minus 2 minus 1 comma 2 lambda plus 1 minus 2, 3 lambda minus 1 minus 4. That is 4 lambda minus 3, 2 lambda minus 1, comma 3 lambda minus 5. These are the direction ratios of AP. Great. Now we have this L, the direction ratios are 4 to 3. We have AP, the direction ratios are 4 lambda minus 3, 2 lambda minus 1, 3 lambda minus 4, and they are perpendicular to each other. Because P is the foot of the perpendicular from A on L. Therefore, this line L and AP are perpendicular. Therefore, the direction ratios are to be multiplied like this. So, if two lines with direction ratios A1, B1, C1 and A2, B2, C2 are perpendicular, then A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So, apply this. So, since AP is perpendicular to L, 4 times 4 lambda minus 3 plus 2 times 2 lambda minus 1 plus 3 times 3 lambda minus 5 is equal to 0. Multiply and simplify, you will get it 29 lambda is equal to 29, lambda is equal to 1. Now with this value of lambda, we can find out the coordinates of P. So the coordinates of P are here, and put lambda is equal to 1 in this, then you will get the coordinates of P. So the coordinates of the point P, which is the foot of the perpendicular, are given by those coordinates 4 lambda minus 2, comma 2 lambda plus 1, comma 3 lambda minus 1 to be evaluated at lambda is equal to 1. Put lambda is equal to 1 in this, then you will get 2, 3, 2. So the P coordinates have come. Now the P coordinates have come and required to find the distance of P from this plane. So the plane is known and the coordinates of P are known. So the perpendicular distance formula from a point onto the plane is known. So substitute and compute that, take that formula and compute that perpendicular distance. We do it in the next slide. We have the coordinates of the point P are 2, 3, 2. Now the distance of 2, 3, 2, which is the point P, from this plane 3x plus 4y plus 12z plus 23 is equal to 0. We recall the formula. The distance of the point x1, y1, z1 from the plane ax plus by plus cz plus d is equal to 0 is equal to modulus of ax1 plus by1 plus cz1 plus d mod closed by under the square root of a square plus b square plus c square. So that will be given here as is equal to modulus of 3 into 2 plus 4 into 3 plus 12 into 2 plus 23 modulus over by under the square root of 3 square plus 4 square plus 12 square. So multiply. So you will get mod of 6 plus 12 plus 24 plus 23 by under the square root of, this is 169, under the square root of 169 is 13, and that is equal to, the numerator is 65 by the denominator is 13. So when cancellation we do it, then we get 5. Thus the perpendicular distance of the point P from this plane 3x plus 4y plus 12z plus 23 is equal to 0 is 5. So let's look at our options. Our answer 5 appears against option A. Therefore, the answer to this question is option A. So that is the detailed discussion of the solution of the problem which is related to a line and a plane in the three-dimensional geometry. So I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.